Experimental test, the modelization. So the idea is to develop modeling from the microstructure to the industrial scale in order to optimize the design. There is many different names from all the universities. So the main goal of this work package is to produce model to be able to make a sensitivity study in order to optimize the microstructure, to optimize the masonry, and etc., to obtain the best vessel from the point of view of the industrial application. To do that, the work package has been divided in 6 tasks. The first one, at the beginning, concerns the microstructure modeling at the micron scale. After, there is the material behavior of the macro scale, the scale of the bricks, the corrosion impact. The idea here is not to model the slag infiltration on all the chemical reaction, but only the impact, the result of the corrosion on the thermomechanical behavior. So it is a simplified approach. Subsystem simulation corresponds to few bricks, or yes, not more than few bricks, or sandwich of refractory. Wall on pilot simulation is a reference to the biaxial hot test press in RHI, and also to the idea of a cylindrical pilot in Tata Steel LED sensor, but also the wall of Minot to the fire resistance. And then, at the end, if all works, we will compute a steel ladder. The most difficult will not be to compute the steel ladder, but to obtain the same result that will be obtained by the measurements on the same steel ladder. But if it don't fit,
you can choose another fit.
We can modify the parameters. So there is a lot of work to be done. The idea is to have a person in charge for each task from the different universities. All of them are not here today because Damien is not here, but he sent me all the information. So the first task concerns the investigation of the relationship between the microstructure and the macroscopic behavior. The idea is to test the effect of the grain topology, the shape, the size, their position in space, to test also the effect of the different properties of the different grains, and to do that by discrete element method, which is a Fashion method for simulation at this scale, with the idea to going to optimize the role played by the microstructure. So we are on the raw materials scale. There is 2 particular points that will be observed: the crack propagation behavior by a wet resisting test and so on, and the flexibility. What is the flexibility of a refractory? A definition to be done. The flexibility for the table shock strength. And this work has already started. There's 2 months now. Not exactly. So it's starting with Farid Asadi here, so probably here. I hope that all is true. So the current work, you have done the thermomechanical discrete element modeling for brittle materials on biography, generality on refractory, nonlinear behavior, micromechanical on in situ DIC. We will start also work with GRANU. GRANU is a free software to make discrete element simulation. If you want to download the software, you just have to click here. It will not work on the presentation, but you can copy and paste in the internet. And if you want some explanation, because it's not so easy, you can phone him. There is the web link. Here it's just an example. The size are not significant because it's in meters, so it's just to play. So each grain is modeled by a small spherical particle, and there is a contact behavior, and then you can observe the cracks propagation here with the main principal stress for the color. So it's only positive stress for this illustration. Next step in the next 2 years will be to apply this method to model the wedge fitting test in order to be able to predict the crack propagation and to compare it with the digital image correlation obtained at room temperature and perhaps at high temperature, if it works, we hope. The thermal expansion mismatch effect with the idea of model materials. And a new thing, try to do the in situ test of tensile test.
It can be different kind of tests. Tension is not very easy, but it can be friction or micro wedge fitting.
Yes, it's easiest tensile. In the scanning electron microscope, to do digital image correlation with this gray and black image, and then to make comparison with simulation at a local scale. Good luck. For the work package 2, the task 2, so the modeling of thermomechanical behavior, we are working at the brick scale. So the idea is to enhance the best existing model for the refractory. There is not a lot of, but there are at least 3 or 4 interesting models for the behavior of a refractory. The idea is to have a model that takes into account the nonlinear behavior. It's important. The non-symmetric behavior between tensile and compression, it's also important, and the effect of corrosion. Only the effect on the thermomechanical behavior. And to obtain that, the idea is to investigate the primary and secondary creep through different approach. This work will start in April 2018, so we are starting working because the PhD student work before the thesis in Orient. He started before to arrive. So Lucas started by a bibliography on the plasticity model on thermodynamic frameworks, which is not an easy work. He started also to try to understand an old UMAT that I have written. There's a long time. There is 1,000 lines and more. And so the first step is to understand this code in Fortran and to make some tests to be sure and to enhance this package. The next step will be the bibliography on quick theory on models, DIC on reverse methods, to be able to apply that on the subject. We will have the idea to do a benchmark of the 3 or 4 interesting models before to make the choice of which one will be enhanced in this thesis. For the experimental part, we will not do it. It's in the work package 2, but we do it a little. We will use bending test, tensile compression, and Brazilian test, all at hot temperature with DIC, and normally it will work. A part of the experimental for the bending will be with Paul in Saint-Gobain. You always agree. For the task 3, the influence of corrosion. So the impact of corrosion, I put on wear because corrosion on wear are always mixed, not so easy to make the partition. There is 2 PhD students that will work on these topics. One in Aaron with fatigue by thermal shock. Yes. And the second one, not only on this topic, on corrosion and on mechanical effect in HGH. So this work will start from the point of view of this work package in 2019, because the first part of their thesis is not this part. So there is nothing for the moment. I just put an old curse coming from Torsten. The fourth task concerns the nonlinear modeling at the subsystem scale. So few bricks, not a wall, a representative elementary volume, accounting for creep and corrosion impact. It's new. In previous work, in the refractory field, the masonry was modeled only with the elastic behavior and the crushing of joints. The idea is to accounting for nonlinear behavior with different techniques, nonlinear homogenization in Orient and surface plasticity model in Minot. So we can make comparison of the advantage and disadvantage of both methods, and also perhaps some modeling in Leoben, but playing with the boundary condition to reproduce the whole vessel. And we hope to accounting for cracked and opening joints. So there will be 2 PhD students on this topic, one in Orient, will start in May 2018, normally all in school, and the second one in Minot, just recruit, starting soon too. After there is the models of the pilot scale. So the idea for this task is to beginning to make a comparison between the model with few bricks and the lab scale, because it's easiest to control the boundary condition, to control the loads. It's not reasonable to go directly to the industrial scale. Here it's a picture of the RHI magnesita, bi-axial hot test press, an old picture, there is 5 or 6 years now, and the corresponding simulation. It's an old paper. The idea is to compute a new test, to make the validation on the calibration of the model. If all works well, we will calibrate the model, so we will play with the parameters only at this scale, not at the industrial scale. In theory. In practice, it will be different. But in theory, we will have to calibrate the model on this scale. So we will have this test, the test of Minot with the wall is 4 meters square.
We can do walls up to 4 meters.
But most of the tests will be wallets like 1.5 by 1.5. I think it will be the most amount of tests. But we can do tests with only thermal load, not mechanical load, up to 4 meters. I think it's the size of the gas furnace.
3 meters.
3 meters.
3 meters. Because here it's 1 meters by 1 meters. Yes. Remember, it's a vertical wall. So it's a roof, not a wall. And for you, horizontal. And for you, it's vertical. Okay, all is plain now. So it's horizontal, it's the roof, and in Minot it will be vertical. Here it's 1 meter by 1 meter. There is mechanical load, so it's a big axial compression, and possibility of thermal loading too, up to
1,400, 500. We have to check this.
Okay.
The mechanical load is not the biggest one. If you are doing it with 1 by 1 meter, then the load is limited to
Yes, I
1 or
remember.
something like this Newton per square millimeter.
I remember because we have done the simulation a long time ago, and I remember that the boundary conditions are not so easy to define. There is a huge work on this topic. So for this part, there will be three PhD students with the different approach on the same computation. And after, the end for the best. The validation at the ladder scale. So the idea is clear, is to compute the ladder and to obtain the same result than the measurement. The first question will be what we what will be measured?
Yeah.
If there is nothing, it will be easiest for us. I think we will have temperature, almost. Displacement will be interesting. Stress will be hard. Strain, if we have the displacement. We will see, we will exchange, and perhaps we will try to put strain gauge in the vessel. We will have to exchange a lot about this topic, and it will be also the possibility to make a benchmark between the three different approaches for the structure modeling in Leoben, Orient, and Minot on the same vessel. And I think it will be really interesting to compare the interest of each method. And it will start in 2021. You have time.
21. It will be the end.
Yes. But it will be the reality.
Nobody will do the same.
It will be the reality.
The result for 21.
The result. So there is a mistake I have to correct. It will be finished.
Yeah. Okay.